Hello, this is Ryan Fisher doing my week two practice problems video for Organic Chemistry 1 with Dr. Kerr. In this video, I'm going to be going over some practice problems as this week we are working on naming certain organic compounds and learning some IUPAC nomenclature. And I found this cool site, Pearson Plus. It was free, or at least it's free for the moment. It hasn't asked me to be charged yet. That gives me questions to solve that are in addition to our homework problems. So I figured I would go through some of these and see what we can find out. So I'm going to zoom in a little bit just because it's hard for my older eyes to see. And the first thing I'm going to be looking for is the longest chain. And just by looking, it looks like the horizontal chain is going to be the longest in this situation, but let's double check. So we have 1 carbon, 2 carbons, 3 carbon, 4 carbon, 5, 6, 7, 8, 9. If we go this way, it'll be shorter. If we go this way, it'll be shorter as well. So 9 is definitely our longest chain, and 9 has the prefix known, N-O-N, and it looks like all of our answers have that. So we can't really get rid of any of our answers just based off of the longest chain. So the next thing we'll look at is what are these substituents here. And I see if we go from left to right, at our second, third, fourth carbon, we have an ethyl group right here. And at our 5th carbon, again, going left to right, we have, well, actually, this is an isopropyl group. So we want to think about which way we want to go here. So if we go from the right, we'll have 1, 2, 3, 4, 5. From the right and from the left is 1, 2, 3, 4, 5. So no matter which way we go, the fifth will be the isopropyl group. So, and then if we're going from left to right, it would be number 4 for the ethyl, and going from this way, it'll be second, third, fourth, fifth, sixth for the ethyl. In this case, ethyl will take preference over the isopropyl. So we'll have 4 ethyl, 5 isopropyl. Let's look at our answers. 5 ethyl, 4 propyl, that's not right. 5 ethyl, 4, 1 methyl ethyl nonane, that actually might be right. Let me think about this. So we have, oh no, that is not right, because the ethyl would be on the 5, which would be here, instead of the 4. So C4, okay, this looks more right. So we have 4 ethyl, 1, 2, 3, 4. So our ethyl's on 4. 5, and then 1 methyl ethyl. I believe 1 methyl ethyl is just a different way of saying isopropyl. I believe it's like the more, I don't know, standard or maybe IUPAC version of the name. So let's just look at this all together. 4 ethyl, 1, 2, 3, 4. There's our ethyl. 5, and then we have a methyl ethyl. So we have an ethyl, say here, and then a methyl right here off of the ethyl. So this makes sense. 4 ethyl, 5, 1 methyl ethyl nonane. So let's click it. Let's check our answer. And it's right. That is the correct answer. All right, let's move on to the next question. Okay, the next problem is a little bit more of a doozy here. Definitely a little bit more of a difficult problem. Let me zoom in a little bit here. So let's look at our parent chain. Let's go a couple different ways. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 is a nonane, which we can see our first answer does give that. 1, 2, 3, 4, 5, 6, 7, 8, 9. Again, that is a nonane. Okay, so one thing that we want to do with IUPAC nomenclature is we want to pick the main chain that gives us the least amount of crazy substituents. So you'll notice if I picked this main horizontal chain for my main chain, I'm going to have an ethyl, a methyl, and then this crazy thing right here. We don't really want that. If we instead use this main chain going right here, then we'll just have an ethyl, a methyl, and then a butyl, methyl, ethyl, propyl, butyl. Yeah, butyl. So with that in mind, we're going to use this as our main chain, okay? Next up, we want to look at all of our functional groups. So we have an ethyl here, We have a methyl here. We have a methyl here and a methyl here. And over here, as I said, we have a butyl, methyl, ethyl, propyl, butyl. So what is important to know with nomenclature on IUPAC is that you want to pick, you want to put things in alphabetical order. Okay, so butyl is the highest on the alphabet. We don't have anything that starts with an A, so B is going to be next. So we're going to have 1, 2, 3, 4, 5, or 1, 2, 3, 4, 5, either way. 5 butyl. So number one, we can knock out we can knock out A right off the bat. We can knock out A right off the bat. And then we have an ethyl. E comes after B and before M. So we're going to have an ethyl, and that'd be 1, 2, 3, 3 ethyl. So we have 5 butyl, 3 ethyl, and then we have 3 methyl. So that's a trimethyl. So we have 2, 3, 4. So we have a 4, 5, 6, 4, 6, 7 trimethyl. Okay, so we have a 5 butyl, 3 ethyl, 4, 6, 7 trimethyl. Wow, that is a tongue twister. Okay, so let's figure out which one is going to 5 butyl, 3 ethyl, 4, 6. Oh, it's right here. 5 butyl, 3 ethyl, 4, 6, 7 trimethyl nonane. Anything else catch our interest? 5 butyl, 3 ethyl, 4, 6, 7 methyl nonane. That is wrong. This puts the ethyl in the wrong position. All right, so this is definitely the right answer, I believe. Let's go ahead and try it out. And it is correct. Sweet. Okay, so this question is a little different than what we were working on. And this is asking us to find the number of carbon atoms from just the names instead of giving us a structure, and then to use the 2n plus 2 rule to find out how many hydrogens we have. So let's start with the dimethyl ethyl hexane. So if we're just looking at, well, first of all, let's start with hexane. Hexane is or hex is the prefix for 6 carbons. So we know we have 6 off the bat. So I'm just going to go up here in my little toolbar and write 6 so I can keep track of all this. And then we have a dimethyl. That is 2 methyls. Each one is going to have 1 carbon. So we have 2 carbons. So we're going to do plus 2. And then an ethyl. So I'm guessing that the 2 methyls are coming off the ethyl, but the ethyl will have 2 carbons of its own. So that's 2. So we have 6 plus 2 plus 2 is 10. So we know that we have 10 carbons. So we're going to insert 10 for n. 2 times 10 is 20. 20 plus 2 is 2. Or 22, excuse me. So which one fits that? And we have C and D. C10H22 fits C and D. So we can pretty much X out A and B, which I will do. Okay, so now let's move on to the trimethyl propyl nonane. So nonane we know has 9, so we'll just put 9 there. And then a propyl has 3, methyl, ethyl, propyl. And we have a trimethyl. That is 3 of its own. Plus 3. And 9 plus 3 is 12. 12 plus 3 is 15. Okay. And as we can see, let's see. C has, down here, 15 and, okay, so they gave 15 for both, so we can't answer from that. So we're going to take 15 times 2 is 30, plus 2 is 32. C shows 30, so this is wrong. But D shows 32. So this one is correct. We go ahead and switch to the pointer thingy. Come down here, check answer, and we are correct. Sweet. So let me go ahead and clean this up and go on to the next problem. Okay, next problem. Going to zoom in here. Determine the alkane's systematic IUPAC name. So looking at it, you can see it too, but just looking at the alkane means we have no double bonds, no triple bonds, so that's good. And let's count the longest chain here. 1, 2, 3, 4, 5, 6. That is a hexane, and it looks like all the answers. Oh, nope, D does not say hexane, so let's go ahead and get rid of that right off the bat. 1, 2, 3, 4, 5, 6. Yep, both ways it is 6. So it's definitely a hexane. All right. Oh, and also I'm just noticing it almost caught me up here. This has E in it. This is also wrong. E is for alkenes, not alkanes. So right off the bat, we're down to B and C. All right. So it is a hexane, and we have two methyl groups. One on the 3 if you're reading left to right, and one on the 5 leading left to right. Reading right to left, we have one on the 2 and one on the 4. So because reading left to, or right to left gets us our lowest number, we're going to read right to left coming this way, and we're going to have 2,4 dimethyl hexane. And that is number C right here. So this is going to be our correct answer. Of course, let's double check because you never know. And that is correct. Sweet. So, all right, let's move on to the next problem. Okay. In this problem, it's basically asking us to identify this structure. So first thing we want to look for is an octane. 2, 3, 4, 5, 6, 7, 8. 2, 3, 4, 5, 6, 7, 8. That one's good. 2, 3, 4, 5, 6, 7, 8. That one's good. 2, 3, 4, 5, 6, 7, 8. These are all octanes, so we can't really get rid of anything off the bat. So the next thing we want to look for is this dimethyl that's on the 3, or the ethyl, it doesn't really matter. And right off the bat, I can see that right here. So 1, 2, 3, or 1, 2, 3, whichever way you go. This is not a dimethyl ethyl. This is just a methyl. So this one's out. C is out. Down here on the 3 here or on the 3 over here, there's no ethyl. So C and D are both out. So that's leaving us with just A and B. For A, it is on the 3 carbon, but this is really a methyl ethyl. So this right here, it's like backwards L can be considered the ethyl, and this right here can be considered the methyl right here. So this is more like our problem earlier we had, which is a methyl ethyl rather than a dimethyl ethyl. However, right below it, we have an ethyl with a 1, 1. They're both on the same carbon. Dimethyl. These right here are our methyls. So I believe that answer B is the correct answer for 3, third carbon. 1, 1 dimethyl ethyl octane. Let's find out. And that is correct. All right, so I think that wraps up because I'm going over time here on my problems for this week. I hope that you enjoyed, and if you have any questions, please feel free to reach out.